Hello, welcome to IT Expert YouTube video series. Today we are going to talk about blockchain explained in 25 minutes. What is blockchain technology? Blockchain, sometimes referred to as distributed ledger technology, makes the history of any digital asset unalterable and transparent through the use of a decentralized network and cryptographic hashing. A simple analogy for how blockchain technology operates can be compared to how a Google Docs document works. When you create a Google Doc and share it with a group of people, the document is simply distributed instead of copied or transferred. This creates a decentralized distribution chain that gives everyone access to the base document at the same time. No one is locked out awaiting changes from another party, while all modifications to the document are being recorded in real time, making changes completely transparent. A significant gap to note, however, is that unlike Google Docs, original content and data on the blockchain cannot be modified once written, adding to its level of security. Why is blockchain important? Blockchain is an especially promising and revolutionary technology because it helps reduce security risks, stamp out fraud, and bring transparency in a scalable way. Popularized by its association with cryptocurrency and NFTs, blockchain technology has since evolved to become a management solution for all types of global industries. Today, you can find blockchain technology providing transparency for the food supply chain, securing healthcare data, innovating gaming, and overall changing how we handle data and ownership on a large scale. How do different industries use blockchain? Blockchain is an emerging technology that is being adopted in innovative manner by various industries. We describe some use cases in different industries in the following subsections. Energy. Energy companies use blockchain technology to create peer-to-peer energy trading platforms and streamline access to renewable energy. For example, consider these uses. Blockchain-based energy companies have created a trading platform for the sale of electricity between individuals. Homeowners with solar panels use this platform to sell their excess solar energy to neighbors. The process is largely automated. Smart meters create transactions, and blockchain records them. With blockchain-based crowdfunding initiatives, users can sponsor and own solar panels in communities that lack energy access. Sponsors might also receive rent for these communities once the solar panels are constructed. Finance. Traditional financial systems, like banks and stock exchanges, use blockchain services to manage online payments, accounts, and market trading. For example, Singapore Exchange Limited, an investment holding company that provides financial trading services throughout Asia, uses blockchain technology to build a more efficient interbank payment account. By adopting blockchain, they solve several challenges, including batch processing and manual reconciliation of several thousand financial transactions. Media and entertainment. Companies in media and entertainment use blockchain systems to manage copyright data. Copyright verification is critical for the fair compensation of artists. It takes multiple transactions to record the sale or transfer of copyright content. Sony Music Entertainment Japan uses blockchain services to make digital rights management more efficient. They have successfully used blockchain strategy to improve productivity and reduce costs in copyright processing. Retail. Retail companies use blockchain to track the movement of goods between suppliers and buyers. For example, Amazon Retail has filed a patent for a distributed ledger technology system that will use blockchain technology to verify that all goods sold on the platform are authentic. Amazon sellers can map their global supply chains by allowing participants such as manufacturers, couriers, distributors, end users, and secondary users to add events to the ledger after registering with a certificate authority. Blockchain security. Blockchain is frequently claimed to be an unhackable technology. But 51% attacks allow threat actors to gain control over more than half of a blockchain's compute power and corrupt the integrity of the shared ledger. While this particular attack is expensive and difficult, the fact that it was effective means that security professionals should treat blockchain as a useful technology, not a magical answer to all problems. The 51% attack takes advantage of what is known as the 51% problem if a single party possesses 51% of a mining pool. It is possible to falsify an entry into the blockchain, allowing for double spending, and even to fork a new chain to the advantage of the mining pool. The two main types of blockchain, public and private, offer different levels of security. Public blockchains use computers connected to the public internet to validate transactions and bundle them into blocks to add to the ledger. Private blockchains, on the other hand, typically only permit known organizations to join. Because any organization can join public blockchains, they might not be right for enterprises concerned about the confidentiality of the information moving through the network. Another difference between public and private blockchains regards participant identity. Public blockchains are typically designed around the principle of anonymity. A private blockchain consists of a permissioned network in which consensus can be achieved through a process called selective endorsement, where known users verify the transactions. The advantage of this for businesses is that only participants with the appropriate access and permissions can maintain the transaction ledger. There are still a few issues with this method, including threats from insiders, but many of them can be solved with a highly secure infrastructure. Blockchain technologies are growing at an unprecedented rate, empowering new concepts for everything from shared storage to social networks. From a security perspective, we are breaking new ground. As developers create blockchain applications, they should give precedent to securing their blockchain applications and services. Activities such as performing risk assessments, creating threat models, and doing code analysis, such as static code analysis, interactive application security testing, and software composition analysis, should all be on a developer's blockchain application roadmap. Building security in from the start is critical to ensuring a successful and secure blockchain application. What are the features of blockchain technology? Blockchain technology has the following main features. Decentralization. Decentralization in blockchain refers to transferring control and decision-making from a centralized entity, individual, organization, or group to a distributed network. Decentralized blockchain networks use transparency to reduce the need for trust among participants. These networks also deter participants from exerting authority or control over one another in ways that degrade the functionality of the network. Immutability. Immutability means something cannot be changed or altered. No participant can tamper with a transaction once someone has recorded it to the shared ledger. If a transaction record includes an error, you must add a new transaction to reverse the mistake, and both transactions are visible to the network. Consensus. A blockchain system establishes rules about participant consent for recording transactions. You can record new transactions only when the majority of participants in the network give their consent. How does blockchain work? While underlying blockchain mechanisms are complex, we give a brief overview in the following steps. Blockchain software can automate most of these steps. Step 1. Record the transaction. A blockchain transaction shows the movement of physical or digital assets from one party to another in the blockchain network. It is recorded as a data block and can include details like these. Who was involved in the transaction? What happened during the transaction? When did the transaction occur? Where did the transaction occur? Why did the transaction occur? How much of the asset was exchanged? How many preconditions were met during the transaction? Step 2. Gain consensus. Most participants on the distributed blockchain network must agree that the recorded transaction is valid. Depending on the type of network, rules of agreement can vary but are typically established at the start of the network. Step 3. Link the blocks. Once the participants have reached a consensus, transactions on the blockchain are written into blocks equivalent to the pages of a ledger book. Along with the transactions, a cryptographic hash is also appended to the new block. The hash acts as a chain that links the blocks together. If the contents of the block are intentionally or unintentionally modified, the hash value changes, providing a way to detect data tampering. Thus, the blocks and chains link securely, and you cannot edit them. Each additional block strengthens the verification of the previous block and therefore the entire blockchain. This is like stacking wooden blocks to make a tower. You can only stack blocks on top, and if you remove a block from the middle of the tower, the whole tower breaks. Step 4. Share the ledger. The system distributes the latest copy of the central ledger to all participants. What are the key components of blockchain technology? Blockchain architecture has the following main components. A distributed ledger. A distributed ledger is the shared database in the blockchain network that stores the transactions, such as a shared file that everyone in the team can edit. In most shared text editors, anyone with editing rights can delete the entire file. However, distributed ledger technologies have strict rules about who can edit and how to edit. You cannot delete entries once they have been recorded. Smart contracts. Companies use smart contracts to self-manage business contracts without the need for an assisting third party. They are programs stored on the blockchain system that run automatically when predetermined conditions are met. They run if-then checks so that transactions can be completed confidently. For example, a logistics company can have a smart contract that automatically makes payment once goods have arrived at the port. Public key cryptography. Public key cryptography is a security feature to uniquely identify participants in the blockchain network. This mechanism generates two sets of keys for network members. One key is a public key that is common to everyone in the network. The other is a private key that is unique to every member. The private and public keys work together to unlock the data in the ledger. For example, Bhumik and Sufin are two members of the network. Bhumik records a transaction that is encrypted with his private key. Sufin can decrypt it with her public key. This way, Sufin is confident that Bhumik made the transaction. Sufin's public key wouldn't have worked if Bhumik's private key had been tampered with. What are the types of blockchain networks? Here are four main types of decentralized or distributed networks in the blockchain. Public blockchain networks. Public blockchains are permissionless and allow everyone to join them. All members of the blockchain have equal rights to read, edit, and validate the blockchain. People primarily use public blockchains to exchange and mine cryptocurrencies like Bitcoin, Ethereum, and Litecoin. Private blockchain networks. A single organization controls private blockchains, also called managed blockchains. The authority determines who can be a member and what rights they have in the network. Private blockchains are only partially decentralized because they have access restrictions. Ripple, a digital currency exchange network for businesses, is an example of a private blockchain. Hybrid blockchain networks. Hybrid blockchains combine elements from both private and public networks. Companies can set up private, permission-based systems alongside a public system. In this way, they control access to specific data stored in the blockchain while keeping the rest of the data public. They use smart contracts to allow public members to check if private transactions have been completed. For example, hybrid blockchains can grant public access to digital currency while keeping bank-owned currency private. Consortium blockchain networks. A group of organizations governs consortium blockchain networks. Pre-selected organizations share the responsibility of maintaining the blockchain and determining data access rights. Industries in which many organizations have common goals and benefit from shared responsibility often prefer consortium blockchain networks. For example, the Global Shipping Business Network Consortium is a not-for-profit blockchain consortium that aims to digitize the shipping industry and increase collaboration between maritime industry operators. What are blockchain protocols? The term blockchain protocol refers to different types of blockchain platforms that are available for application development. Each blockchain protocol adapts the basic blockchain principles to suit specific industries or applications. Some examples of blockchain protocols are provided in the following subsections. Hyperledger Fabric. Hyperledger Fabric is an open-source project with a suite of tools and libraries. Enterprises can use it to build private blockchain applications quickly and effectively. It is a modular, general-purpose framework that offers unique identity management and access control features. These features make it suitable for various applications, such as track and trace of supply chains, trade finance, loyalty and rewards, and clearing settlement of financial assets. Ethereum. Ethereum is a decentralized open-source blockchain platform that people can use to build public blockchain applications. Ethereum Enterprise is designed for business use cases. Corda. Corda is an open-source blockchain project designed for business. With Corda, you can build interoperable blockchain networks that transact in strict privacy. Businesses can use Corda's smart contract technology to transact directly, with value. Most of its users are financial institutions. Quorum. Quorum is an open-source blockchain protocol that is derived from Ethereum. It is specially designed for use in a private blockchain network, where only a single member owns all the nodes, or in a consortium blockchain network, where multiple members each own a portion of the network. What are the benefits of blockchain technology? Blockchain technology brings many benefits to asset transaction management. We list a few of them in the following subsections. Advanced security. Blockchain systems provide the high level of security and trust that modern digital transactions require. There is always a fear that someone will manipulate underlying software to generate fake money for themselves. But blockchain uses the three principles of cryptography, decentralization, and consensus to create a highly secure underlying software system that is nearly impossible to tamper with. There is no single point of failure, and a single user cannot change the transaction records. Improved efficiency. Business-to-business transactions can take a lot of time and create operational bottlenecks, especially when compliance and third-party regulatory bodies are involved. Transparency and smart contracts in blockchain make such business transactions faster and more efficient. Faster auditing. Enterprises must be able to securely generate, exchange, archive, and reconstruct e-transactions in an auditable manner. Blockchain records are chronologically immutable, which means that all records are always ordered by time. This data transparency makes audit processing much faster. What is the difference between Bitcoin and blockchain? Bitcoin and blockchain might be used interchangeably, but they are two different things. Since Bitcoin was an early application of blockchain technology, people inadvertently began using Bitcoin to mean blockchain, creating this misnomer. But blockchain technology has many applications outside of Bitcoin. Bitcoin is a digital currency that operates without any centralized control. Bitcoins were originally created to make financial transactions online but are now considered digital assets that can be converted to any other global currency, like USD or Euros. A public Bitcoin blockchain network creates and manages the central ledger. Bitcoin network. A public ledger records all Bitcoin transactions, and servers around the world hold copies of this ledger. The servers are like banks. Although each bank knows only about the money its customers exchange, Bitcoin servers are aware of every single Bitcoin transaction in the world. Anyone with a spare computer can set up one of these servers, known as a node. This is like opening your own Bitcoin bank instead of a bank account. Miners collect these transactions into a new block and add them permanently to the blockchain, which acts like the definitive account book of Bitcoin. Bitcoin mining. On the public Bitcoin network, members mine for cryptocurrency by solving cryptographic equations to create new blocks. The system broadcasts each new transaction publicly to the network and shares it from node to node. Every 10 minutes or so. Mining requires significant computational resources and takes a long time due to the complexity of the software process. In exchange, miners earn a small amount of cryptocurrency. The miners act as modern clerks who record transactions and collect transaction fees. What is the difference between a database and a blockchain? Blockchain is a special type of database management system that has more features than a regular database. We describe some significant differences between a traditional database and a blockchain in the following list. Blockchains decentralize control without damaging trust in the existing data. This is not possible in other database systems. Companies involved in a transaction cannot share their entire database. But in blockchain networks, each company has its copy of the ledger, and the system automatically maintains consistency between the two ledgers. Although in most database systems you can edit or delete data, in blockchain you can only insert data. How is blockchain different from the cloud? The term cloud refers to computing services that can be accessed online. You can access software as a service, product as a service, and infrastructure as a service from the cloud. Cloud providers manage their hardware and infrastructure and give you access to these computing resources over the internet. They provide many more resources than just database management. If you want to join a public blockchain network, you need to provide your hardware resources to store your ledger copy. You could use a server from the cloud for this purpose too. Some cloud providers also offer complete blockchain as a service from the cloud. Interview question and answer. What is the fundamental tenet of the blockchain? The distributed ledger is the underlying premise of blockchain technology. In this manner, each peer has a copy of the whole ledger including all modifications, making the ledger completely secure. Blockchain ecosystem. What are the essential elements? Explain. There are three key components to the blockchain ecosystem. A shared ledger. A blockchain's logical component. It's a decentralized system. Node application. A node software is a program that lets the computer communicate with the blockchain. Consensus algorithm. There must be a consensus method in place so that all of the nodes can agree on the blockchain's rules. Is proof of stake and proof of work the same thing? Using proof of stake, blockchain developers can create the next block depending on how much a person has staked, which is dependent on how many coins they own on a specific blockchain. While in proof of work, the miners compete with one another to finish network transactions and be paid. Here, users exchange digital tokens in a network. What kinds of records can be stored on a blockchain? The blockchain may protect all forms of records. Also, new solutions may be effectively built depending on the kind of transactions. The following are examples of common sorts of records. Medical transaction records. Self-identity protection. Execution of business operations. Transactions in the business world. Documentation of any kind. Other organizational tasks. What is the objective of a blockchain node? Blockchain engineer interview questions will also focus on knowledge of individual components in the basic stage. Blockchain comprises multiple blocks of data, which are stored on nodes. The nodes on blockchain could be any form of device ranging from bigger servers to personal computers. The primary objective of the blockchain node is the development of blockchain infrastructure. The blockchain nodes are connected to each other and are constantly engaged in exchanging the most recent blockchain data with each other. What is the difference between a blockchain ledger and an ordinary ledger database? Blockchain engineer interview questions would also turn attention towards the advantage of blockchain ledger over conventional ledgers. Blockchain ledger is digital in nature and provides ease of decentralization. Therefore, a blockchain ledger includes limited risks of errors in comparison to the database. Furthermore, blockchain ledger ensures automatic execution of all the tasks. What are the promising advantages of blockchain technology? The benefits of blockchain technology are numerous. Cost efficiency. Better traceability and transparency in transactions. Improved controls over fraud. User anonymity. Immutability of transactions. Complete relief from intermediaries and associated costs. Automatic account reconciliation. Improved security. Explain the trapdoor function. The trapdoor function is suitable for easy computing in one direction, albeit with difficulties for computing in opposite direction without special information. The trapdoor functions are important to implement blockchain for ensuring public key encryption. Trapdoor function is implemented in blockchain development for representing the ideas of private keys and addresses. What is the RSA algorithm? The RSA algorithm is also a notable topic for blockchain engineer interview questions. RSA is the acronym for Rivest-Shamir-Adleman Consensus Algorithm. RSA algorithm is suitable for encryption and decryption of messages by leveraging modern computers. Most important of all, RSA is an asymmetric algorithm, implying that it has two different keys, a public key and a private key. What is the importance of security policy in blockchain? The security policy in blockchain is basically a brief and formal plan revolving around the organizational objectives, procedures, and goals for achieving information security. Basically, it provides the description for all tasks required to ensure security of blockchain from external threats. The security policy also outlines the approaches for managing situations where security threats occur. Thank you for watching this video. We provide hands-on training with labs, homework, group projects. Prepare you for the certification. Provide real projects. Internship opportunities. Support you and resume LinkedIn. Staffing support. Provide tech references. In-person online class. Class retake options and more. Call us at 847-350-9034 for your free career consultation meeting. Please do not forget to like, share, and subscribe to our channel for the latest videos.